All right, so this next video is on attributes of sinusoidal functions. A lot of this is a review from last unit. It's just a review of the values of the thetas in comparison with the x and y coordinates of the unit circle. But now we're going to look at them independently so that we can explore sine and cosine. Now, when we hear a sinusoidal function, that is going to mean sine and cosine. They are both sinusoidal functions based on their attributes. And also cosine is just sine, but it's just shifted over pi over 2. Okay, so it's going to share those same attributes. Okay, so on the unit circle, we're specifically looking at sine theta. So we're looking at the y values. Okay, and if you notice on the unit circle, we have this symmetry. We have the y values are going to be 0 here. As we go up, the y values will be 1/2. And then from here, the y values will be root 3 over 2. And then the y value is 1. Now, something we're missing on this table is our root 2 over 2. That's going to be here. Okay, so you should start to see well, if you didn't see them from last unit, you need to start recognizing that symmetry, especially for sine, because now we're looking specifically at the y values. Okay, so if we look at our unit circle, I'll try to align the colors with these coordinates. At sine of pi over 6, that's going to be the red. That's going to have an output of 1/2. At pi over 3, that's going to be the blue. Sorry, that's not the blue. It's going to be the tan because we're skipping family of 4s. That is going to be root 3 over 2. And then pi over 2 is going to be at the top here. That's the full radius, which will be 1. And then as we start to decrease, we are coming back to the tan, which is root 3 over 2. Still positive because we're above the x-axis. And then next we have 5 pi over 6, which is the red. And then at pi, we are back to where we started, 0. So now we're going to start working our way into the negative values. And you'll still see that symmetry, except it will be negative. So the y value here is negative 1/2. And you'll see that across the circle, that reflective symmetry. And then we'll have our family of 4s, but we're not looking at them on here. Okay, and that'll be negative root 2 over 2. And then we have our tan with the distance. We're getting further and further away from the x-axis. So now we're at negative root 3 over 2. And then we'll have our maximum distance, which will be negative 1. Okay, so 7 pi over 6, that's going to be our negative 1/2. And I just noticed I wrote 5 pi over 6 in here when that should have been just 1/2. Sorry about that. And then 4 pi over 3, we're now moving further away from the x-axis. So that's going to be the tan value. So that will be negative root 3 over 2. And then 3 pi over 2 is the furthest, so we'll get negative 1. And now we're working our way back towards the x-axis. So we have negative root 3 over 2 at 5 pi over 3. And notice they're both families of 3s. All family of 3 for sine is going to be some form of root 3 over 2. If you're above, it's positive. If you're below, it's going to be negative. And you'll see that same relationship for family of 6s. We're closer to the x-axis, so it's just going to be negative 1/2. That's going to be the same for all family of 6s. And then your family of 2s, those are going to be your maximum distance from the x-axis. So we have positive 1, negative 1. And then for 2 pi, we are back at 0. Okay. So I'm going to try and align again. So we're starting at 1/2 for sine. Align the colors. At pi over 6, it's 1/2. And then at pi over 3, it'll be root 3 over 2. Root 3 over 2 is about 0.866. So I'm just going to graph it right below the 1. And then at pi over 2, we're at 1. And then at 2 pi over 3, we're at root 3 over 2 again. And then at 5 pi over 6, we're at 1/2. And then at pi, we are at 0. And then once we start working our way below the x-axis, we go to negative 1/2. And then negative root 3 over 2. And then we're at 1 again. Negative 1, sorry. And then negative root 3 over 2. Negative 1/2. And then now we are back to 0. And then it's not in our table, but sine does cross the origin, so we'll go ahead and put that in. okay? And as we go through the points, we end up with our sinusoidal curve, which we talked about in the last unit for Trig's functions. So if you look at the unit circle compared to our sinusoidal curve on the graph, you can still see that relationship to the x-axis, but now we're traveling to the right instead of just going around the unit circle infinitely, okay? So these next few attributes are going to be important for trig transformations, which we will talk about in the next video. So for the midline, we have another sketch down here that we're going to use. Your midline is going to be, it's in the line, in the title. It's going to be the line that slices your sinusoidal curve exactly in half, okay? So this will be halfway, B/W, that's just going to be between. So halfway between the max value and the min value. So the maximum and the minimum value. And what's going to affect this is going to be, I don't want to talk about that yet. We'll save that for when we talk about A, B, C, and D. Now there is a little formula for this. If you want to find the midline, you can do the max plus the minimum divided by 2. So you're taking the sum of the maximum and the minimum, that full distance, and then you are dividing it by 2. That will give you the location of your midline. And in this case, our maximum is at +1, and then our minimum is at -1. So we end up with, hold on, sorry, that should be divided by 2. So we end up with 0 divided by 2, which is 0, which is what we see here. Now your amplitude, that is going to be the distance from the midline to the max value or the min value, the minimum value. And there is a formula for this one as well. Your amplitude will be the max minus the min divided by 2. So in this case, our maximum output is 1. The minimum output is -1. So we end up with 1 plus 1, which is 2/2. So we get 1. So the amplitude is a distance, all right? The amplitude is going to be the distance between the midline and the maximum and the midline and the minimum. And if we look at this, we can see that this has a distance of 1. Your period is going to be the distance. Your period can be the distance from any point to any point once that is repeating again. So if we look at sine specifically, like I see this point here, we're crossing through the midline and it's increasing. So if I continue to follow my graph, I cross the midline here, but I'm going down this time. I'm not increasing through the midline. So I decrease through the midline, and then I come back, and then I see this event occur again. I'm increasing through the midline again. So I can see that this is cycling through, which shows me that it's the start of a new period, okay? So you can use any part of the graph, but in this definition, I say the distance from max to max or min to min. And we say those points because they are unique attributes that we can easily see, okay? And to talk about the period for a function, I'll talk about that when I talk about A, B, C, and D, but there is a formula for it, okay? Your frequency, that is going to be the number of times a repeating event occurs per unit of time. per unit of time. So that's basically asking, okay, how often will I see let's say this maximum? How often do we see a maximum within this period of time? And because this is a sinusoidal curve without any transformations, the period is 2 pi. Well, how many maximums do you see on this graph? I see one. So within this period of 2 pi, we only see it happen once. So once every 2 pi, we will have a maximum. That is our frequency, all right? Another way to look at it is if you have your period represented as p, your frequency will be equal to 1 over p. So it's just the reciprocal. So if you're, say that p is equal to it's going to be your new period. But in this case, we're just looking at 2 pi. So the frequency for this graph would be 1 over 2 pi. Okay, we'll talk about those. Yeah, we'll talk about A, B, C, and D a little bit later. All right, so for cosine, not much is going to be different, except now we're going to be talking about the x-coordinates, all right? So cosine theta is equal to the x-coordinates. So now I will try and use some more color coding. So if we look at our x-coordinates, we can see that starting at the origin, we're going to have 0, 0. X-coordinates are going to be 0 on the y-axis. If we travel to the right, we're going to see that family of 3s. We're still closer to the y-axis, so we're going to have an x-coordinate of 1/2. And then we have our family of 4s in here, but they're not going to be in our table, which is okay. But those are our root 2 over 2s. And then family of 6s, we have root 3 over 2. And then finally, the furthest distance out will be our 1, okay? So this is, I guess we're going to do quadrant 1 and 2 first. So I'll go ahead and fill it out on the other side as well. So we have 2 pi over 3, 4 pi over 3. Our x-coordinates will be negative 1/2. The blue will be our family of 4s. And then the tan will be our family of 6s. So that'll be negative root 3 over 2, negative root 3 over 2. And then we have the pink, which is going to be negative 1. All right, so pi over 6, that's going to give us cosine pi over 6 is going to be root 3 over 2. That's going to be the tan. And then pi over 3, we're going to start moving closer to the y-axis. So that's going to be the green, or teal, seafoam, I don't know what that is. So we'll have 1/2. And then pi over 2, we're on the y-axis, so x is going to be 0. 2 pi over 3, we're now moving to the left of the y-axis, so that is negative 1/2. And then 5 pi over 6, we'll have the tan, which is negative root 3 over 2. And then finally for pi, we're at the furthest distance from the y-axis, which is negative 1, that radius. Now we're going to start coming back, okay? So now we're on the tan, we're coming back towards the y-axis, so negative root 3 over 2. And then we're coming back to the odd green, so 1 over 2. Sorry, negative 1/2. And now we're back to the x-axis, or the y-axis for 3 pi over 2, so 0. And now we're in quadrant 4, which is where cosine is also positive. So now we'll have positive 1/2, positive root 3 over 2, and then positive 1, which is where we started. All right, so if you notice, same relationship, all of the family of 6s for cosine are going to be root 3 over 2 because they are the furthest, except for the ones and negative ones, from the y-axis. All right, and that same trend follows for all the families. So I'm going to go ahead and graph this pretty quickly because we did the same for sine, but for cosine, we're going to start at positive 1, and then we follow the same trend, root 3 over 2, 1/2, 0. And then negative 1/2, negative root 3 over 2, negative 1, negative root 3 over 2, negative 1/2, 0, 1/2, root 3 over 2, 1. And then we're ending where we started, okay, with a maximum. So from max to max, I see that 1 period, and it's going to have a period of 2 pi. Now the nice thing, the midline, same as sine. same attributes, same formula. And then amplitude, same as sine. Because again, cosine is just a form of sine, it's just shifted over. And then same thing for period, same as sine, frequency, same as sine, okay? So the graph of g theta, which is the graph to our left, is cosine theta oscillating between concave up and concave down. So that's important. We talked about concavity a lot in first semester. So on this particular graph, when we're passing the x-axis, those are your points of inflections. And those are important because we can use those to write functions for sine. If we were to shift this point here to the y-axis, we would end up having sine, okay? And then at the bottom, it just shows how cosine is sine. It's just shifted over pi over 2 to the left. Okay, so sine and cosine are both sinusoidal functions. Okay. All right, so example 17. So two periods of the sinusoidal function f theta are shown in the figure above. Find the period, frequency, amplitude, and the midline of the graph. Okay, so now first let's look at the period. So I want to usually you can start from the y-axis and then you want to see, okay, when does this event occur again? So right now I see that I'm passing through what looks like the midline here, slicing that sinusoidal curve in half. I'm passing through the midline and I'm increasing. So when do I do that again? So I have my maximum, passing through the midline, but I'm decreasing a minimum, and boom. I'm seeing that same event occur again, passing through the midline, increasing, passing through the midline, increasing. And I can see that I'm going from 0 to pi. Now you can also do this with your maximums if that's easier. I have a maximum here and I have a maximum here. Now this one's a little harder to see because it's not specifically labeled. So that's why it's better to use multiple ways in order to find an event that occurs again. So for this one, I can see that I have the event here and I have the event here. Therefore, the new period for this, so new period, you're going to see that written as capital P, which is equal to pi. So the new period for this particular sinusoidal curve will be pi. Frequency is just going to be the reciprocal of the period, which is equal to 1 over pi because my period is pi. That just means each event occurs once. So within this 1 pi, I have one maximum. I have one minimum. I have one time that the sinusoidal curve passes the midline and it's going through decreasing or it's going through increasing. Okay, so each event only occurs one time every pi. The midline. So the midline, if you have a graph, graphically, it's usually going to be pretty straightforward. I can see that my minimum is at 0, my maximum is at 6, therefore my midline will be halfway, which is at 3, all right? Or you can use that little formula, which is max plus min divided by 2. You take the total distance between the max and the min, and then you slice it in half. So we have 6 plus 0 divided by 2, which is equal to 3, which is what we see on the graph here, that it's at 3. Amplitude, again, graphically we can see it if you draw a midline in, but now we can look at the distance from the midline to the max, or the midline to the minimum. Now, amplitude is distance, so it will always be positive. So if we're going from 3 to 6, that means your amplitude is equal to 3. Or you can use that same formula, but now you're subtracting. So for this one, it would be max minus minimum divided by 2, which is equal to 6 minus 0 divided by 2, which equals 3 again. All right, 18. Several periods of the sinusoidal function g theta are shown in the figure above. Find the period, frequency, amplitude, and the midline of the graph g of theta. So if we look at this, the period. So now if we look at the y-axis, we're now actually starting at a maximum. So the next time that you see a maximum, right there. That means this has a period of 1/2, okay? So my new period, which is P, is equal to pi over 2. Yeah, maximums and minimums, they're usually the easiest ones to see. Minimum isn't really notated on here. I mean, we can split it in half, but you want to be efficient. Frequency is going to be the reciprocal of the period. So we get 2 over pi, which makes sense, even though it's set up a little bit weirder than the other ones. This is saying that for each pi, we will have 2 events, okay? Which, let's look at the maximums. So within this first cycle, I have a maximum, I have another maximum, and that happens within 1 pi, okay? So this here is not included because it's the start of a new cycle. So that means the new cycle would be here. Sorry. The cycle is pi over 2, but our frequency is in terms of pi. So we have 2 maximums per pi. The midline, we can go ahead and use the formula. So we have 3 plus -1, taking the sum of the max and min divided by 2. So we get 2 divided by 2, which is equal to 1. So my midline is going to be at +1. Again, you can also just use the graph for that. So if I look at this graph from the midline to the maximum, I have a value of 2 units. So that will be my amplitude. So that means amplitude is going to be 2. All right, the sinusoidal function h theta has a maximum at point pi8. The first minimum after reaching this maximum value occurs at the point 3 pi -2. Find the period, frequency, amplitude, and midline for the graph of h theta. So anytime that you're giving coordinates, I would graph it, all right? Makes it a lot easier to see what's going on. So our maximum is at pi8. So we'll have pi, and then we'll have 8. And then our minimum is at, where is it? 3 pi -2. So now we're going below -2. So we're going to see something like this. Okay, so going from max to max gives us a period. Going from max to min or min to max, that's just going to give us half the period. So 1/2 p. So if I look at this from pi to 3 pi, I have a distance of 2 pi, which means if I want my full period, I need to multiply this by 2, okay? So if I have 2 pi times 2, that's going to give me a period of 4 pi. Frequency is just going to be the reciprocal of the period, so a maximum is going to occur once every 4 pi. Each event only occurs once every 4 pi. The midline, this one's not so obvious, so I'm going to use the formula. So I have maximum plus the minimum, so 8 plus -2 divided by 2. So I end up with 6 over 2, which is equal to 3. So my midline is going to be at 3. And then now, since I have the midline in there, it's a little bit easier to see the distance from the midline to the maximum, which is going to be 5, and that will be my amplitude. So once you have period, it's easier to find the frequency. And then once you have your midline, it's easier to find the amplitude, which is why we have it in this order. Okay, so this is actually an FRQ model question, number 3 actually, from the AP exam. So I'm going to pause this and then, or you can pause it to read it if you want. I'm not going to read the whole thing. So if you want to read it real quick, go ahead and pause it. Otherwise, I'm going to move on to part A. So part A is saying the graph of H and its dashed midline for 2 full cycles is shown. 5 points, F, G, J, K, and P are labeled on the graph. No scale is indicated. No axes are present. Determine possible coordinates. Inputs are T, outputs are height for the 5 points, F, G, J, K, and P. So within this scenario, it's discussing the hands of a clock, and the maximum height from the ground that the clock will reach when it strikes 12 is 128. The minimum here, when it strikes 6, is going to be 112, which means the midline, or the middle part, when it strikes 9 and 3, is going to be halfway in between this. So this is going to be 120. So what we're doing is, think of this as the unit circle. And then now we're unraveling the unit circle into a sinusoidal curve like we see down here, okay? So with this one, it did say at F, it's going to hit 128. No, it says at time t equals 0 minutes, the minute hand is pointed directly up at 12, which would be the 128. So that means F here is going to be at 128. Here's our minimum of 112, and then our midline is going to be at 120. So that means because it's hitting at t equals 0, we're hitting it's pointed directly up at the 12, we can say that this is t equals 0. And it completes a cycle in 30 minutes. So that means we have a maximum at 0, which means 30 minutes later, we'll have another maximum. And then these will always be in equal intervals, all right? So J will be halfway, so 15. Halfway between 0 and 15 will be 7.5. Halfway between 15 and 30 will be 22.5. So now to determine possible coordinates, I believe we already did this. Let me scroll up real quick, because we've done it. I've done it so many times in class. I can't. Yep, we did. It's right here. So it's example 6. So if you want to get those coordinates from there, you can, but it's going to be the same concept. Okay. So now I'm going to come back to this one. So what's happening is these FRQ questions, there are several parts for them. Basically, we did the first 2 parts up top, and now we're doing the next 2 parts because we talked about period, frequency, amplitude, and midline. So now part B says find the period, frequency, amplitude, and midline. So for the period, we already talked about going from max to max, and it takes 30 minutes to complete one cycle. So that's going to be 30. Not all of your periods will be in radians. If we're in minutes, then that will be the unit. So the frequency is just the reciprocal of the period. So we can take that 30 and flip it. So it'll be 1 over 30. So how often does the clock strike 12? Once every 30 minutes. How often does it strike 9? Once every 30 minutes, because it's broken and it's going twice as fast. The midline, we can just pull directly from our, it's not a graph, it's just it is a graph. There's just no scale or axes. We can use that 120 for that. And then our amplitude is just going to be the length of the hands in the clock, which is 8 inches. So we'll have 120 to 128, so amplitude is 8. You can also just use the distance between here. Part C says find 2 intervals for which the graph of h is both decreasing and concave up. So this is similar to what we talked about from the earlier example in one of the previous videos. It is decreasing from F to J, but based on this point of inflection, it is concave up from G to J. Okay, so we're looking at this example specifically. So the graph, full sentences for this one, of h is decreasing and concave up on the intervals. It's asking for 2 intervals. On the intervals 7.5 to 15. So I can see that G to J is going to be 7.5 to 15. And we need another interval. So when will this occur again? Well, my frequency is 1 over 30. My period is 30. So this will occur in each cycle. So every 30 minutes, this will occur. Which means if I want to find the next time that this occurs, I can add 30 because that's going to be the next time that this event occurs again. So 7.5 plus 30, we get 37.5. And then 15 plus 30, we get 45. So technically you could also add 60, you could add 90, you could add 120. You could add anything that is a multiple of 30 and this event will occur again. However, I recommend keeping it low just because you don't want to raise the chances for errors. Okay, hope this helps.